We have shown the link of this GeoGebra file that we are showing here, and we know that GeoGebra is openly available on internet, and when you will click on the link in the description bar, then you will see this file. And here I have tried to represent the mission and vision of our geometrifying trigonometry. From our childhood and from our school days, we know that we have seen this kind of pictures sometimes, and sometimes we could understand it and sometimes we could not understand it. But reality is, every trigonometry expression is representable as the geometric representation of the Euclidean style, Euclidean geometry way, where every line segment has a name. Suppose this line segment is taken as the 1. In geometrifying trigonometry, we take it as the L, capital L, that is the initial line segment, and if the beta is known, then its projection is here, and if we take this part of the triangle as the initial triangle, since we have taken this hypotenuse as 1, then this part of the line, this line segment is cos beta, and this line segment is sin beta, since it's the perpendicular and this is the base. Now forget this one for short time. If we take this one as the 1 or the initial line segment, then this could become the cos alpha. Now the secondary side effects, you can see the effect of the multiplication here. 1, this line segment is taken as a 1 or L. If we take this as the L, capital L, then this will become the L cos beta. This line segment will become L cos beta. And if we take this as the L cos beta, then it is the hypotenuse of the second triangle, and then this will become the base of the second triangle. This line segment will become the base of second triangle, and so this cos beta, L cos beta into L cos alpha, this is shown wrong. Cos alpha should come later on. It should be written as the L cos beta into cos alpha, which means the cos beta is done first, then cos alpha is done second. In numerical value, cos alpha into cos beta and cos beta into cos alpha is no difference, but in geometry, if we write it in wrong order, then its meaning is different. Similarly, this one is the cos beta, so this one is the cos beta into sin alpha. This is also written in the wrong way. Now if we forget this blue triangle and if we consider this one only, 1 sin beta is the projection, that is the perpendicular, this one is the sin beta since this angle is beta, and if sin beta is taken here, then this turns into hypotenuse for this white triangle, and sin beta is written first, then this one becomes base. Think of it as a rotated object. If we consider it as a rotated object in this way, then we will see the concept easily. So we are using GeoGebra here to understand it better, because this one is the 1, or in geometrifying trigonometry we call it L. If this one is the L, then this one is L sin beta, and this one becomes L sin beta cos alpha. So we should look at the pictures differently whenever we need to visualize the whole things geometrically. This is the good habit of visualizing trigonometry. But we don't see trigonometry in this way. Now if this one is the alpha and this one is beta, the total angle is alpha plus beta, and if we draw this whole rectangle now as per the properties of Euclidean geometry, and the transverse line is taken here and these two lines are parallel, and if these two lines are parallel, then this angle is alpha plus beta, and if this one is 1, or in geometrifying trigonometry we call it as L, then obviously this one becomes a perpendicular, because in that case we have to check it in this way. We should look the whole picture in this way, and that will give us more clarity. Suppose the picture is rotated, and now we can show how this thing is behaving. Suppose this one is the L. Now this alpha plus beta and is the angle. Here it is the transverse angle and it is the alpha plus beta. Now in this white triangle, this line segment becomes the sin alpha plus beta, because this one is the angle, this one becomes a perpendicular, this one becomes a base, so it is the cos alpha plus beta. Similarly, if we look this whole thing in this way, and now if we try to see the picture, here, this one is the 1 or L, it is L sine beta. Now this is taken as the hypotenuse and this one is the alpha, so this one is the base, this small line segment is the base. So L sine beta should be written first, then cos alpha is multiplied later. In this way it should be written as the L sine beta cos alpha, but they are writing it in the reverse order, so the geometry should change. Here this is not formalized diagram, it is just to represent you. So numerically the length of the line segments are not disturbing us, but practical construction mechanism will reverse, because is as per the formalization of geometrifying trigonometry and the reality of the engineering drawing systems, or if we have to think it in the more formalized rigorous way, then we should think everything in a proper way, and it is non-commutative geometry. Writing cos beta first and cos alpha first or sin alpha first changes the whole story. So as per this picture, numerically the lengths are okay, sin alpha sin beta and sin beta sin alpha are same thing, but geometric construction will change drastically if we take it in the reverse order. I have to say it here because the geometrifying trigonometry works with more drastic rigorous formalisms. Now come to this picture. So many times we have written several equations of trigonometry, we have written several expressions of trigonometry where cos alpha cos beta plus sin alpha sin beta is equal to cos alpha minus beta, because it is a part of the parallelogram, and cos alpha minus beta is proven here where it is showing that cos alpha cos beta plus sin alpha sin beta. But is it really so? In this case this line segment is taken as the 1, and if it is 1 and if this one is the beta, then this one is done first, which is sin beta, and again it is alpha, so it should be written as a sin beta sin alpha. Instead in this picture they are showing it as a sin alpha sin beta. This is wrong way to write. It should be written as a sin beta sin alpha, because from this one, the line segment 1, that is L, or the L is the given line segment, where we are taking 1 is more important thing. When we are taking this one first, then this triangle is the first triangle on which we have to focus. When we are focusing here, then this sin beta should come first, and this sin beta is the hypotenuse for the next triangle on which we are trying to analyze. So sin beta should be written first, then sin alpha should come. This way of writing is wrong, and we should not take it as a commutative algebra. We should take it as a non-commutative geometric construction mechanism. So we have to become more rigorous and we have to become more formalized. We have to think the whole thing, whole picture with more clarity of the actions written in a sequential way. If we are doing sin beta first, that means we are focusing on this line segment just after this one, and that is the L, which is the given line segment. From this initial given line segment L, we are getting this sin beta line segment first, then we are getting sin alpha line segment. So we should write it as a sin beta then sin alpha. So it should be written as the L into sin beta into sin alpha instead of this wrong convention. These wrong conventions are practiced in our daily life, and we have seen these kind of things everywhere, in every diagrams, in every book, but that confuses us while we construct the geometry, mainly when we try to formalize and we have to make the programs to automatically generate these pictures from the given expression. Suppose in the trigonometry expression you are writing cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta, then it should automatically change the expression that cos alpha minus beta means it is to be considered as sin beta sin alpha plus cos beta, cos alpha. It should not write in this way. That I am trying to say here, because geometrifying trigonometry is very strict about this ordering of systems, and it tries to generate this kind of pictures automatically. And we will show in our different videos explain all those things there, and this GeoGebra file is already in the link of the description of this video, from where you can check all these files by zooming, by dragging, by rotating, as I have shown here to you. Now in the separate video I have already shown how to get the geometrifying trigonometry simulator such that you can use it properly, and we have shown the way how to generate several kind of geometry generation from the multiplicative options of the expressions. Now I want to show you how to search the automated trigonometry simulator from Google, and you have to type geometrifying trigonometry to get several theory in the GitHub pages, in the Coda, and in several other places also you will get this data. And there are the lecture videos also available in Bengali language especially, but there are the pictures in the images. You will get the multiplicative mechanisms, especially on this case, where you will see the explanation of multiplication is visualized in a separate video today. I will show you how the additions are done in the image. From this image in Google you can get the multiplicative mechanism. It is shown stepwise very well. It is shown there, and there are list programs available in the freely available in Autodesk forum, where you will automatically get redirected from you will get this redirected from Google, so it is not the big deal. Here I want to show you, if you search with automated trigonometry, in Google, then you will find this, this link, where I am trying to show you this link here. This one is the link. If you search with the automated trigonometry, then you will get this link. Here you will get the exe file as the attachment, and there are several Bengali lectures on the geometrifying trigonometry and its theory, how it works. That will help you to understand the way to think about the geometrifying trigonometry. And in the separate video today I have already shown the how to run this simulator tool. This simulator tool automatically generates the multiplicative pictures of data. In another video today we will launch the how to do the plus and minus, mainly plus, minus, and into, divide. These things are main thing for any algebraic structure. We will try to show how the length segment, triangles, and the points are the algebraic objects in geometrifying trigonometry, and how to deal with those things. It is a special kind of algebraic structure where it is different from the vectors, because vectors have plus, minus, into, and no division is there. But in geometrifying trigonometry we handle with the line segments, triangles, and points, where plus, minus, into, divide all are very well defined. Plus are of two different types, minus are of two different types, and they have the four symmetries each: sine, cos, tan, cosec, sec, cot. Everything has the four types of the symmetries. So 24 types of the variety of geometrical constructions you can get for every kind of multiplication. And we will demonstrate everything separately in separate videos. We will show you all how to construct the geometry manually and also automatically through the parser designing and through compiler designing of the trigonometry expressions or the algebraic expressions or infinite series, anything, such that we can generate the Euclidean geometry out of the expressions given in our book or in our exercise problems or anywhere. especially for bridge designs or for any kind of girder designs or jewelry designs or any kind of geometric object designing. We use trigonometry expressions and algebraic expressions, but we have seen graphs. We have seen graphs of the sinusoidal waves or several kind of things. Those are not actually geometry. We here are showing the art of doing geometry, the Euclidean geometry way of explaining the expressions that we have not dealt in other subjects too much. We can simply say the geometrifying trigonometry is an algebraic new kind of algebra where we deal with the line segments, triangles and points. And in the input part on the left side of this simulator, you can change the values, you can change the commands. There is a separate video where I have shown cos cube theta, sin cube theta, tan cube theta, and the total 24 options I have shown with the demonstrations. And here we can change the angles of the seat angles, which is a theta, such that from here, and here we can show the construction mechanisms with which the stage wise each line segment construction I have told you before in this video, where the commutative actions and the non-commutative actions are the different behaviors. And we have shown that the cos alpha cos beta has a different picture than the cos beta cos alpha, that you can see here by changing the sliders and by typing here the commands in the different orders, in the swapping the orders. Then you can see the change of the geometry due to the changing of the seat angles. And you can change the seat angles from the slider also from 0 to 360 degree, and also you can change it from here. Both options are available. And all cos, all sine, tan, cos, that is add sugar to coffee, that is for quadrant wise the geometric arrangement changes. So up to 0 to 90 degree you can get different symmetry. From 90 to 180 you can see different kind of symmetry. All these things will become visible to you when you will run this simulator. So we are using mainly two different softwares. One is the GeoGebra for dynamic constructions and dynamic animations and all those things, and there is a separate simulator that is entirely developed by me and is freely available in Autodesk forum. And with that you can test with especially for the geometrifying trigonometry cases. GeoGebra is a generalized software for geometry and algebra calculations, and it's a beautiful software for demonstrations and for understanding and for analysis of algebra and geometry together. It's a very well-known software, and NCERT of Indian education systems is also using it for demonstrations now, and it is a very popular now. And this one is entirely developed by me for the visualization of geometrifying trigonometry operations, its parsing actions, it's how the expressions are dynamically changing when we are changing theta values, that is the seat angles, and how can we generate the theorems out of that. We can design our new theorems, we can design new sub varieties of the theories out of this geometrifying trigonometry. Stepwise we will proceed with these things. And this software has also a powerful feature that it can generate SVG files to the scale, it can generate DXF files to the scale, such that we can directly import it in the Tekla and the StatPro. It generates the StatPro files also for structural engineering. It generates the Tekla model importers, the dump files also. It generates IFC files also. We will come to all those things later on in different videos. Thank you. We will please check the other videos where we have demonstrated every different kind of mechanisms, and the GeoGebra file links are always there, and those are freely available from the links. And GeoGebra is a open source and open visibility software for the students and for professionals also, so that we can interoperate and intercommunicate between each other. And GeoGebra GGB files are also downloadable from the site, from the systems in your local machine, such that you can download it as the GGB files, and GGB files are zip files, and if you rename it .zip, then you can extract the data and you will get the XML files or the JSON files, and from which you can understand the construction protocols that you can see here. And the construction protocols generations are always available in the GeoGebra systems, where if you make it on, then you can see the construction protocol, the sequence of the operations that we have done to prepare this document. or for any kind of simulations, that helps everyone to understand what are things done stepwise to get up image or get a logic in the geometry, Euclidean geometry logic. We will talk about only Euclidean geometry and the construction protocols, and which we will generate automatically from given trigonometric